All right. Um, okay, can you guys see my screen? Yeah, okay. So this is going to be a relatively long presentation. There's a lot of content to share and maybe possibly discuss. And um, uh, let's get started. Hopefully, if you have questions, please write them down for the end. So maybe if we have time, we can talk about them. For this presentation, we're going to basically first see the presentation goals, what is a schema, and an introduction to Malli, and use cases, conclusion, and maybe next steps. And as I just said, questions, hopefully we can get there in time. Cool. So the goal of this presentation, not most of you probably don't know, is to share the results of experiments that I did in a separate branch in our repository using Malli. And this presentation doesn't expect any of us to know Malli. We'll go from scratch. But the intent is to share knowledge and have a shared understanding of what is Malli, what are schemas, how we can take advantage of these things, and see if we can actually use in our repository, maybe if possible. And also have some fun, because presentations don't happen very often. And why not start to do this more often? Okay, so a schema, first of all, the definition of a schema is overloaded. But if you take the definition of a database schema, it fits well with the Malli schemas, which is a specification for describing types and how they can be represented in the database, the attributes and the relationships between them. For Clojure, for our context, it's basically, we can think of schemas as a blueprint for Clojure data structures. Malli was a library created by Metazine, which is well known in the Clojure community. A library created around 4 years ago. It was funded already by Clojures Together, which is an initiative that I don't know if all of you know. It's a really nice initiative to fund open source projects in the Clojure community. And sometimes this allows maintainers or library authors to work full-time in their projects. And this greatly speeds up and increases the quality of libraries. It's a nice strategy that I'm sure other communities do, but Clojure in particular, being a very small community, to build better quality libraries, this becomes especially useful and important. Malli has been improving steadily over the years based on community feedback. If you know the history in Clojure, you know that Clojure spec was created many years ago by Rich Hickey, and their spec evolved mostly based on Rich Hickey's ideas, and the community felt a need over the years to make some changes, improvements, etc., that were hard to be implemented in the core spec library. So over time, Rich Hickey as well got involved with other projects, and spec kind of stopped evolving, and that's where I think one of the big motivations for creating Malli. Interestingly, there is a new Clojure dialect being created called Jenk, which will eventually implement a gradual type system inspired by Malli's syntax. Okay, and so Malli is not a new library. It has been used. It is used in many production systems. I used Malli in my previous job successfully. It was a different runtime. It was running in Node, so not a mobile app. And we also evaluated if we should use Clover spec or not, and we went for Malli. But this presentation won't be comparing Malli and spec. As the author said, they can coexist and even be friends. And spec is an awesome tool for writing and describing library APIs, and Malli, the world we're living in. So I find this a really interesting idea. Malli is pragmatic and practical for our needs. We're not library authors. So let's get started with a bit of syntax. So a schema in Malli, and I hope all of this makes sense for people who are just starting with Clojure as well. So a keyword can be a schema. Here, int says that any integer is a valid value according to this schema. Schemas can also have properties. So if you wrap it in a vector, what Malli calls the vector syntax, you can pass a second element, which is a map of properties saying that the integer must be greater or equal to 1. They are composable, of course. You can have the or schema saying that the value must be an integer or a string, and enumerators saying that they must be of some color, maybe blue, or in this case, blue or orange. And here's a different one, maybe not so common in statically typed languages. You can say that a schema, the value should match a regular expression. And a map of strings to keywords. Here we see a difference. The first argument, the string function is an actual Clojure core function, whereas in the previous examples, the schema was a keyword, right? This is because in Malli, any function, any predicate function that returns true or false, whatever the function does, is a valid schema or predicate for schemas. Here's a practical example that we see all the time. When we write keywords for translations, we have to qualify the keyword with the T namespace, and we can verify this as well. There are dozens and dozens of available schemas. Often they are very easy to use, and it's encouraged that we write our own. We could create, for instance, a schema for a public key, for externization color. Sorry, there's a blah, blah, blah. Oh, so elegant. Sorry, I won't jump into the comments. If you have something that may require, if you think it's important, please interrupt me. No problem. So you can describe also a map. In this case, the example is X, Y, and Z. Z is optional, which means the key is either present and the value is an integer, or the key is not present at all. And the map is open. We'll see. We'll talk more about this soon. So let's keep moving. And you can have arbitrary predicates. This is what I was mentioning before. Here we take the same map, but we pass a second schema, which is the function schema, where you can validate basically anything based on the actual value passed. So if you pass a map with X and Y, it will check that, first of all, the types match, but also that the value of X is greater than Y. Cool. This is an example, a real example taken from the branch I mentioned, where we describe an RPC call to status go. As we can see here, we can define the schema, make it as strict and precise as we want. Here, the method could be just a string, but we can also use a regular expression saying, okay, it must start with walk_ext underscore. And later on in the presentation, we'll see why we might want to do this. And the onSuccess is either an event vector or a function instance. So this works. The next one is how you define in Malli a function schema. We'll talk a lot more about this soon. In this case, it's saying the function expects an integer and returns a string. It's a bit weird, but you get used to this. It's always the same recipe. And here, a much more complicated one, but it's just to show you a real example that I coded in the branch. This one is defining a schema that completely identifies the activity center data stored in the appdb. So here we close the map, which means that only the keys specified in the schema are valid. If you make a typo, for instance, it will generate an error. If you add a new key and so on, this will be considered an error. Richie Hickman, he created Clojure Spec, and in many of his presentations, he usually said that maps should be open and not closed. You shouldn't care about new keys in a map. Your system should just work because it's more flexible and so on. But the community, in general, in production systems, we feel the need to be more strict and say that the contracts we create shouldn't accept new keys because this may be a bug in whoever is calling the function. So closing maps is very, very useful. It just makes, it will just cause more errors to happen sometimes, which may be exactly what you want. And here we see a custom schema being used. We don't need to see how it's implemented, but it's just to show you that we can write our own schemas. Here it's a notification is saying the notifications sequence is optional, but if it is set, it must be a sequence of notifications. And this keyword schema.shell/notification is registered in a global registry. So that's how it works. There's no magic. You register your schemas and you can use them whenever you need. Okay, so that was all about the syntax. It's actually pretty simple. It's always the same, and you can nest them however you want. Now, what can we do with these schemas? In general, we can do 4 things and derive derive value from these 4 categories. We can validate data, instrument functions, transform, or generate data. And you can choose to do only one of these things. For instance, in my previous job, we only used transformations. We didn't instrument, validate, or generate data. In our project, I have the feeling that it will be the opposite. So there's no right or wrong. It's a library. So let's look at validations. So validations, we're using the schema that we saw before for a map. We refer to a validate function in Malli, and we get that same data structure representing a map, and we store in a var named schema. And we can call validate, pass the schema in the valid, and it returns either true or false. The question mark at the beginning of the var is just a convention to name schemas. There are other conventions like using camel case. It doesn't matter, but it's good. It's important to stick to a convention. Malli internally used the question mark prefix and also the camel case. So it's a bit confusing, but for the presentation, it's going to be prefixed with question mark. And another example is you call validate with y as nil. And this is possible because we use the maybe schema, which makes the key nullable or any value nullable. And in the last one, it fails because returns false because z is a string. And if something fails, now the question is, how do we know what has failed? Just as Clojure Spec, Malli provides an explain function, but this explain function returns a data structure that's not meant to be consumed by humans, right? It's meant to be processed for other reasons. So it's pointless for us. Thankfully, there's no need to install a separate library as in Clojure Spec to to see a more meaningful error message. And so Malli has this explain in to function for development purposes only to prettify the error. And now it's much better. It's saying that z should be an integer, and it identifies that x and y are not important in the error. So it adds 3 dots. And this works really well, especially for more complex data structures. This one is simple, of course. And Malli gives us full control over how the error messages are generated. And this one we are seeing here is already customized a little bit because I wrote a report to make it a little bit less noisy. So, okay, let's jump to a practical use case of assertion of validations. So one of them is problem test assertions in ClojureScript can result in cryptic output when comparing nested or large data structures. If you ever faced a failure in our code, a unit test failure, and you had to understand what has failed, you probably, I don't know how you do this, but you probably need to copy the output and format somehow to identify the differences. I'm sure there's a library in ClojureScript that allows us to better diff data structures. In Clojure for the JVM, this is trivial and there are many options. But in ClojureScript, the default behavior is terrible. And so one solution is to define a match function that it's very similar to the explain function we saw, that verify the value matches. And if it does, it returns the value. Otherwise, it prints a humanized error and it fails the test. That's the difference. And I implemented such function. It's not difficult. And here we see a few examples. So match int 42 returns 42 because 42 is an integer. And if you assert it, it returns null because there's no error. Now, if we want to test the find answer to life function, here it's suspicious because the function is returning hello string. That's probably not the answer to life. But in the test, find answer to life returns an answer. And we want to match and see if it's an integer and if it's equal to 42. Clearly, it's going to fail. And it says that the value hello is not an integer because it expects an integer. Another, you can go further and we can consider not using Clojure predicates to verify things in tests. So in this case, it's the input that we want to test. We want, for some reason, test that the name is Alice. We want to make sure. And we don't care about the age. We just want to make sure it's an integer. So we call match, but match fails and says that the name should be Alice. And then the test fails. This is quite nice. It's a contrived example, but with more complex data structures, this can be quite powerful. I don't think we should be using this all the time, but on a case-by-case basis, this can lead to better comparisons and output when errors happen. So yeah, we normally would use the equals comparator, but we use the equals schema instead. Okay, another use case. So this one is more complicated. Our repository, our project, AppDB, is quite large, complex, and in great part, it is modified by untested event handlers. It's easy to introduce errors during development and hard to debug what has caused them. A partial solution might be to implement a sort of schema on write semantic to guarantee that we only write validated. The developer we would quickly get feedback and know precisely what has failed. That's the theory. I know that this was sort of attempted in Status Mobile. Andrea told me that there was a motivation some time ago to try Clojure spec and see if specking the AppDB would be valuable, but didn't go too far. I think the value wasn't justifying the effort. But with Malli, things might be a bit different because it's easier to write and maintain schemas with Malli. Okay, but I still think that it's very easy to implement this. I know that other production apps do this in Reframe, and this is not a novel idea, but it can. I think it's a trap to try to do this in the beginning, because in the beginning you don't have schemas in your system. It's like trying to type your entire system, let's say in TypeScript, and it might not be the best to do. You should probably focus on simpler, smaller uh, functions and places, and not the whole app state, which involves a lot of data models, etc. But it can have an enormous benefit to generate data. We'll talk more about this at the end. So for validation, that's all. Some projects use validations for validating forms and web applications. You can go crazy. In our case, I could only think of these problems. Now, instrumenting functions is a fascinating topic, and very, very interesting. And we do have problems that I think can be solved by instrumentation. So instrumentation is a mechanism where a function input and or the output are automatically checked against its function schema. So it's similar to some kind of compiler, but it doesn't happen at compile time. Everything is at runtime in Clojure. Here, an example, we have an add function. We are summing two numbers, but maybe we're concatenating two strings. We don't know. In JavaScript, this does work. So adding a schema for this is just saying, referring to the var and saying that you accept two integers and return an integer. And then if you call the function with valid arguments, it returns the value as usual and no error. If you call it with a keyword instead, the keyword to, JavaScript concatenates automatically, will convert to a string, concatenate them, but this will be considered an error. And Malli will catch this because the var has been instrumented. And here, the error is a bit different. Sorry, it says the var function, it identified the var function, and it tells you add, receive these arguments, but the output should be an integer, and it was a string. This example is maybe confusing because it's telling us that the output is an integer, should be an integer, but we also didn't it validate the argument, the input? It did. For reasons I don't understand, sometimes if the input and output fail, it will tell you that only the output failed. And if you fix the output, it will then tell you that the input failed. But it will always catch the errors, the invalid values. So a very important question to answer is that I faced. This was a challenge to think what should be done in our project. When an instrumented function is called and it receives invalid inputs, what do we do? Should we print? Should we throw an exception? Should we show a message on the app screen? It depends, or all of the above. It obviously depends. For instance, there are trade-offs to every decision. If we were using Clojure on JVM, we would probably just throw an exception because that would stop the program. For the majority of the cases, it would stop the program and you would be able to see the message and act on it to solve. More similar to a compiler error that stops the world and forces you to fix the error. But when we are developing the app and we have hot reload, all these things going on, we don't want to crash the app. You probably want to just be aware of the error. So maybe not just printing on the standard output, because who's looking at the terminal all the time? You probably want to warn the user in the UI. If we throw an exception, you will see a log box. I tried this, but I hate log boxes. Maybe some of you hate log boxes as well. And many times the app doesn't recover after some types of errors happen. And this was the case here. So you have to reopen the app sometimes, which basically makes the solution of throwing an exception and showing the log box not ideal for a developer experience. So somewhere in the middle, where in development we show some kind of hint in the app, just like we show when we are reloading, hot reloading the app, and the user can, the developer can press on it and look at the error or look at the terminal output. But when we are running tests, we probably want to test the short circuit and fail as soon as an error is identified. And that's how I configured Malli for our repository. I'll show you some examples. So let's go to a more a practical example. Let's say quote components can have many variations and receive many arguments. And mobile devs resort to writing doc strings as with type annotations, but they often get outdated and can't be verified by a machine. This has been the source of a few discussions and pull requests, and one of the motivations for me to start actually testing Malli in our project, because I wanted to get rid of these type annotations because they don't scale well, and they are tedious to write. Maybe if you're using ChatGPT, it helps, but who knows? So the solution is to instrument code components, which are just functions, and replace type comments with schemas. So we're going to look at a simple example, which is the number tag component. Here's just a bit of code that shows the view internal and the view var standard stuff. We see that the destructored arguments are number, size, blur, and theme. But the props map also may contain a type keyword that's not destructored here. You have to drill down into the style container function and another function inside to see that the type can have two possible values. This happens very frequently with us Clojure devs. And maybe there's a better way when we want to have more restrict APIs. And the core library is even, there's a library in the name. We call it the core library. So maybe it's a good place to define schemas for the public interface. So here the schema has been stored in the var. It returns any. As you can see, the second value is any. We don't care about the return value. It's hiccup, but who knows what's inside this hiccup? And the arguments, there's just one, is a map. It's closed. No new keywords or different keywords are accepted. The type, as I mentioned, can be just one of rounded or squared. The number is actually a string. It's not an integer. And you identify these things while you were trying to reverse engineer the arguments and the types and see, okay, what are the types and the possible values? It's quite interesting. The size is an enumerator as well, and theme is optional, and it's a custom enumerator. It's just an enumerator saying it's either light or dark. And when the public var is instrumented and we add a namespace keyword named number tag, okay, we'll soon see to easily identify where the error happened. I don't know if I mentioned, but instrumentation is only meant for development purposes. It's never enabled in production. There's zero cost in production. Okay, just as similarly, we don't have compilers checking code in production. Doesn't make sense. So this has no cost and only development. Now, when we run the component tests for this component, I intentionally changed the argument to make it to pass ABC. And ABC is not a string of digits as the regular expression schema is specified. So it should fail, and just fails because I configured it in Schemas so that it, and in Malli to throw an exception and log the error. And that's what we see. Another, it's important to reiterate that the function only fails because we called it. There's no static check. Okay, we need to call it somehow. Cool. Another use case, interesting. there are 120 quote previews, and there will probably be more. Maybe we'll eventually reach 200 previews. Although they are easy to maintain, we still have trouble maintaining preview descriptors up to date with the source implementation. Preview descriptors are the fields that the user can customize in the UI, and sometimes designers use this as well. And it's a very useful and cool feature for us to make sure components work. But many times we forget to keep them up to date. I saw this many times. And so the solution is to automatically derive descriptors from the instrumented functions. It sounds like magic, but it's really not. We just have a transform the data structure from a data from the schema to the vector of input fields, descriptor we call. So for the number tag, this is the descriptor written manually, and our goal is to generate this data automatically. The way we would do, and I wrote a generate descriptor function, which takes the schema. That's why we made it public in the namespace of the number tag. And then it returns a very similar piece of data. But as you can see, the options, the size options don't have the humanized names. Okay, so we could go further. I didn't. And we can actually think of generating entire preview namespaces on the fly and not write a single line. So this is possible. This would be possible if we just allowed the schema. In the schema, it could be to say the name of the field, the human name, and the initial value. This is worth exploring in the future. I didn't, because I only wanted to prove that descriptors can be generated automatically, and it works really well. So yeah, preview initial and preview show are often things that we have to customize, but can be automated. So a question that I know was made in one of our retrospectives, maybe. I think Jamie had this, and Andrea mentioned about ideas to make sure that only parameters that generate valid variations are possible. And the answer is that we can do this, of course. And there is a specific feature in Malli, which is multi-schemas, which is the same idea of multi-methods in Clojure. So based on a type or any function, you dispatch a different schema. And so that's how you could make sure that, certain variations are impossible. This can be very useful for more complex components like buttons. Buttons have many variations. This can be very useful to give fast feedback during development when errors happen. And the next question is, what should we instrument? There is a very, very common question over the years where people ask, what should we instrument? Because this is not a gradual type system, right? And we should treat instrumentation differently. It happens in the runtime, and there are different trade-offs in how you use these things. And we should avoid instrumenting all the functions. I know that someone that worked in Nubank told me that some of the projects, they were not using Clojure spec, amazingly, because Rich Hickey was working there, and they weren't using Malli, but they were, I think, using a library where they instrumented every single function. And the person said it was really kind of a nightmare to work in the code base. Because they were not focusing on specking, writing schemas only for the parts that interface with the outside world or the internal interfaces. So the recommendation is to instrument parts of the system that internally or externally send data, receive data, and you need to create a stronger contract between caller and the source and the caller. Another idea is to instrument highly reused functions. So for instance, some quote components, not all of them, maybe all of them, okay, but might not be worth. We have many components that only have one call. We could add schemas for React Native namespaces that are highly reused. This can be very valuable. We can also instrument event handlers and subscriptions. I did this in the branch. I will show you a quick example. And because they are often reused many times, can be very helpful. And we have a data store namespaces, and we could add schemas for functions inside these namespaces because they deal with data models coming from status go. And again, it's instrumentation never enabled in production. And gradual type checking is not instrumentation. Let's be careful not to go this route of instrumenting everything. Okay. The next thing that we can do is transform data. And we won't go into detail about transformations. As I said in my previous job, this was the most important thing that we would do. So the idea is that every schema can define how it's encoded and decoded from strings or JSON, Eden. And this allows you to sort of create an anti-corruption layer, which is, the idea that, for example, practical example, signals coming from status go or any RPC response is automatically, in a uniform way, transformed, according to the schemas, is transformed to the closure data structures that we need inside the mobile app. Doesn't matter how they come from status go. We have this nice layer that converts them automatically. And then we don't need to manually call rename keys and other things, which are very error prone. And I know that I reviewed and I made myself a few errors, and I reviewed some bugs that were fixed because of these manual interventions for data transformations. We can also encode the RPC requests before sending them to status go. And that's not as valuable. In general, our RPC requests are very simple. We don't send like large data structures. This can be helpful, and it was in my previous experience. For instance, if you want to persist something in the database, you want to make sure that you are converting the data in your language, programming language enclosure, to SQL, to something that's correct for SQL. Or you could be calling a much more complex API, and internally you have a date instance, and you want to encode that as a specific string to call the API. So all these things are handled nicely with transformations. All right, so the last thing is data generation, which is a fascinating topic, and it's vast and full of, it has a greater API surface and a steeper learning curve, but it can be very rewarding. You play a lot with generators using the REPL. So the basic idea is that you can, if you have a schema, why not generate random data that conforms to the schemas? It can be quite powerful. We'll see some examples. So custom generators, first of all, can work in Clojure Spec, work with Malli, and vice versa. In the Clojure community, all of them come from the test check library, I think. So here's one example. We require the generate function, refer to it, and we generate an integer. And we keep calling it, it will generate different values. We can pass properties to the schema, like the minimum and maximum values, and it will return something that respects these properties. One of the important things to realize here, if you've never done data generation like this, is that somehow generate needs to randomly generate a value that respects the properties. How does it do it? Well, it needs to try, and it may try, I don't know if it's 50 or 100 times by default, and eventually give up. This happens if the schema cannot be shrinked over time, because there is an idea of shrinking the set of possible values until eventually some value matches. So this can be also slow. Okay? And that's where custom generators come in, and you have to write custom generators sometimes to add the hints to tell how to generate the data more efficiently. Here's an example of generating respecting the schema for the map. You see that the second example, it generates a map without the optional total key. Quite cool, right? And here, a wrong implementation of how to generate a random emoji hash, but nonetheless useful, interesting, I would say, because you could say that the emoji hash schema is just a string, a vector of strings, but you could also say that, but when you ask it to generate data, it will just generate garbage strings. And if you want something that resembles more the real data, you can write a custom generator and return something like this. So, problem. In unit tests, calling instrumented functions, it's necessary to pass valid arguments, valid structures, long structures like write messages, notifications, but writing them by hand is long and tedious. So a possible solution is to write or use an existing schema, generate the example data in the test, and assoc only the minimal amount of data to fulfill the assertions. So this is an example, a more detailed example. It's testing that the event handler here, events marked as red, is, again, it's a contrived example, but it's real. It's verifying that we generated the correct RPC request. And the way it does this is it generates a random notification that conforms to the schema, the custom schema that I wrote, and I assoc only the minimal amount of information for my test. Then I generate the activity center itself with the notifications, and then I generate the coeffects, and then this coeffect is valid and mark as red is I'm more certain that mark as red is going to be called with has a correct implementation. And the point here is that if this is what happens usually in Clojure or languages like Clojure. If you have a test where you manually define the inputs for a test and you have no compile time checks, what happens is that if someone changes how the shape of this data should be, your test will continue to pass because the implementation didn't change and the test didn't change, and the test is deterministic in this case. So it will just continue to pass, but you will have a bug in production. So if we define a schema, an instrument of the function, and we generate the data in the test, we have a higher likelihood that we will catch an error if we used an incorrect information. So try to explain again because this was confusing. If someone renamed the read key, right? If we have the schemas, then the function is instrumented, the test will fail because it will tell me that I'm calling a function with an invalid map key. And without schemas, the test would just continue to pass. And the implementation would be incorrect. So other ideas, this is like, if you start to think about generators, you can have lots of ideas. One of them is, let's say we can add a button in each preview screen that when we press, it will randomly generate valid inputs and for the descriptor and update the preview state. This can be very handy to see if your component behaves with a variety of different inputs. Because normally with developers, we only pass happy path data, right? We have a limited amount of time and we don't test all the possible edge cases. So by randomly generating the data and seeing on screen, this can be quite helpful, and it's easy to implement. We can also show a button that when you press, it will ask you how many instances you want of that component. and it will generate as many variations as you want, like literally hundreds of variations, whatever you need. This can be very helpful again. We can also generate parts of the app to inspect the app. So for instance, if somebody asks you to see how all notifications look like in the activity center, you wouldn't have trouble doing this because there are lots and lots of possible states and different types of notifications. If the app.db had a schema for this part of the state, you could generate and see on screen. Surely the app won't work if you press on the notifications, but you would be able to see them rendered on screen and see if it's correct. You could also generate hundreds of messages in different states and so on. So generating data is very powerful for inspecting the runtime and doing things that would be impossible otherwise, or very inconvenient. Malli generators stand on the shoulders of this test check library, and test check was inspired by quick check, which was written in Haskell for Haskell, of course. Test check is said to be a property-based testing. We won't go into detail about this, but the idea is that our unit tests usually are example-based tests. We hard code the examples, and hopefully we write good enough examples to cover the function behavior. But property-based testing is different. It says, let me generate the data for you as long as you give me good enough generators. And I will check that the properties that you defined hold true. If not, the test will fail. And it's a nice complement to a test suite based on example-based testing. Because this can be relatively slow if you wouldn't replace your entire test suite with property-based testing. It's seen as a complement and one that we could take advantage if we had schemas in the code base, because we can just use the schemas for that. Now, about performance, you might be wondering if Malli is fast enough, and Malli is much, much faster than ClojureSpec. It's one of the reasons why it was adopted by production projects, real projects, because ClojureSpec was quite slow, and officially the core team said, for instance, don't validate data if you're concerned about performance. It's not the case with Malli. Sometimes benchmarks show that it's even faster than idiomatic code when doing data transformations. So validation, coercion, and other things that we haven't seen can be used in production just fine. But I do wonder if this is going to have any impact, meaningful impact in our mobile universe. So instrumentation has zero costs, but who knows the cost of other things. To conclude the next steps, Malli is flexible. Schemas can be progressively leveraged. We don't need to commit to any big decision. We can use as much or as little as we need. And complexity can go up in some areas, particularly related to data generation, right? There is a learning curve, but we can ignore it as well, this part, this feature, capability. And a schema-driven approach can help us tackle this, our large code base, which has already more than 100,000 lines of code, that with low test coverage and high churn, which is the worst scenario, right? So the schemas can in fact help us, I believe. I hope I showed you some useful examples, but I'm sure we would be able to come up with others. There's always the chance that we will be introducing accidental complexity or incidental complexity as well. Any library of this caliber can cause such effects. And that's why I think we should start simple. And maybe a plan for using Malli would be to add the plumbing code to the repo, to the repository, which should be quick because I did most of the work. This was the hard part. And we can instrument a few widely used components like the button and see how other devs react to this and see their opinion, and then repeat and let more developers be familiar with this schema-driven approach and write their own schemas for and instrument other components. And eventually, as we mature these ideas and the patterns, we may attempt to solve other problems. Some of the ones, some examples I showed you today, like automating preview screens and all sorts of stuff. And that was it. I hope I finished in time. It's a lot to cover. So yeah, if you have questions, or if you prefer to ask them later as well, just send me or share on the Discord channel. If you think this is not the way to go, no problem as well. No personal feelings attached. So first, James' question, yes, Malli's documentation is the README in the repository, and it's pretty, it's complete enough that you can learn by yourself a lot of the things that I shared today. If you also use the REPL, you have to experiment a lot in the REPL to get a hang of this. Yeah, so there's someone, I think, who raised Alex. If you
Hello. So if you don't hear me right, but I think about the data generated
Alex, is
and
hard to understand.
oh, sorry. All right.
Yeah, if you could repeat now, maybe. Okay, no problem. So I'll share the links and the branch. I'll push the branch right after the meeting. Just give me a couple minutes. I have to clean up some stuff that I did just for the presentation, and it should be there. There's a lot more in the branch. And yeah, I can share other resources as well. And as I said, we don't need to commit to any decision now. That was the presentation. But since we are here, if we want to talk about next steps, I'm open, all ears. Okay, so Alex, your question is, in which scenarios will we need to generate mock data from schemas? So during development and using the REPL, I faced this need many times. As I said, for instance, let's say I want to check the performance of a component, and I need a few variations or hundreds of variations of it on the screen. How do I do this? I can write a loop and generate a fixed set of components, a specific set of properties for the component, but I won't be able to see lots of variations. Sometimes I felt the need for this. I want to see lots of variations, lots of components to check how the app performs. So it's mock data, but it's fine. That's exactly what I need. Other times you would generate mock data for the tests. You don't want to write a monstrosity of a map in the test. You just want to generate something that fulfills the schema, and then a sock, whatever you need. And other times, so yeah, it's meant basically for development. You using the REPL would probably use this to help you, to guide you, to understand how the app behaves, and so on. The more you use it, the more it makes sense, because it's a new topic. So I know that if you are into JavaScript, I know that JavaScript, for instance, a few years ago released something inspired as well by test generation and generative testing, and having its own generators. So it's something that's catching up in other programming languages. Came from Haskell, but it's catching up. Cool, guys. If you have any other question, any moment, please ping me or share on Discord. That was it. Thank you for being here. I know it interrupts all of us. Okay. Bye, guys.
Thank you. Bye.
Thank you. Nice one. Bye.
Bye bye.
Thank you. Bye.